Adjoint of a matrix. For any square matrix A, adjoint of A is defined as the transpose of a matrix obtained by replacing all elements of matrix A by their cofactors. So, which means adjoint of A is just the transpose of the cofactors. So to find the adjoint of A, first we need to find the minus. So minus is denoted by Mij. After getting minus, we need to find the cofactors, which is denoted by Cij. And the relation between the cofactors and the minus is Cij is equal to minus 1 of whole power I plus j into Mij. If I plus j is a even, then Cij will be equal to Mij. If I plus j is odd, then Cij will be negative of Mij. After getting cofactors, then we need to find the adjoint of A, which is nothing but the Cij of Cij ka transpose. So let's take an example. A matrix A is given and we need to find the adjoint of it. So to find the adjoint of A, first we need to find the minors. Minors are M11, M12, M21, and M22. So how to find the minors? For M11, take A11 and hide its corresponding row and column. The remaining entry will be the M11. Similarly for M12, take A12, hide its row and column. The remaining entry will be M12. Similarly for M21, it will be B, M22, it will be A. After getting minus, you need to find the cofactors. We have already discussed the relationship between the cofactors and the minors. So C11, 1 plus 1 is an even number, so it remains same as M11. Here 1 plus 2 is an odd, so it's negative of M12. Sorry, it is M21. Again, this is odd, it's negative of M21. This is even, so it remains the same of M22. After getting cofactors, we need to find the adjoint of a matrix A, which is nothing but the transpose of cofactors, which is D minus C minus B and A transpose, which is D minus B minus C and A. This is the required adjoint of a matrix. There is a trick to find out the adjoint of a matrix A, but this trick is only valid for 2 cross 2 square matrix. In this trick, adjoint of a matrix A is found out in this way. Let's take an above example, a matrix A, B, C, D, and we need to find the adjoint of it. Here simply we need to interchange these diagonal elements, which becomes D comes here and A comes here, and take the negative of non-diagonal elements, which is minus B and minus C. Hence we got the required adjoint of A matrix. Determinant. It is a unique number associated with a square matrix, and it is denoted by mod of A if A is a square matrix. For example, a matrix is given and we need to find the determinant. How to find the determinant is just multiply the diagonal elements first, which is 1 into 6, minus multiply the non-diagonal elements, which is minus 3 into 2, which is 6 plus 6, that is 12. This is the determinant, or this is the unique number associated with this square matrix of order 2 cross 2. This concept is important to find the adjoint of a 3 cross 3 matrix. So let's take an example. A matrix A is given of order 3 cross 3 and we need to find the adjoint of a matrix? I already told you, first we need to find the minus. The steps are same, but a determinant concept is involved in the 3 cross 3 matrix. So to find the minus, we also have here M11. Again, we have M12 and we have M13 also because it is a 3 cross 3 matrix. Then we have M21, M22 and M23. And we also have M31, M32 and M33. So how to find this M11? So same, take the A11 element and hide its corresponding row and corresponding column. The remaining elements, take the determinant. So to take determinant, first multiply the diagonal elements, which is 1 into 3, 3, minus of non-diagonal elements, which is plus 6. So it becomes 9. Similarly for M12, take this element, hide the column and hide the row, and this, 3 twos are 6, minus of 3, which is 3. For M13, hide this column and row, multiply these elements. You take determinant of these elements. 4, 4 minus of minus 1, which is plus 1, and it gives 5. Now for 2, 1, hide the column corresponding to this A21 and row. The remaining entries take the determinant, which is 1 3s are 3, minus 2, which gives 1. Similarly for M22, take this element and hide the remaining 3 plus 1, which is 4. For M23, it is 2 plus 1, 3. For 3 1, take this element and this, you'll get minus 3 minus 1, which is minus 4. For 3 2, minus 3 minus 2, which is minus 5. For M33, take this, and this. The remaining will be this 4, which is 1 minus 2 minus 1. Now we got the minus. From the minus, we need to find the cofactors. So it also has all these elements. C11 is the 1 plus 1, it's an even, so it remains same. C12, it's an odd, it's the negative of M12. C13, even, so it remains 5. C21, odd, negative of M21. C22, even, remains the same. C23, it's the odd, so negative of M23. C31, it's an even, so remains the same. C32, it's the negative, so it becomes 5. C33, it's the even, so it remains the same. So now we got the cofactors. From this, we need to find the adjoint of a matrix. So which is the transpose of the cofactors. So what we got the cofactors? 9 minus 3, 5, minus 1, 4, minus 3, minus 4, 5, and minus 1. Take the transpose of this and you'll get the adjoint of it. How? 9 minus 1 minus 4 minus 3, 4, 5, and plus 5 minus 3 and minus 1. This is the required adjoint of A.